Alright guys, so here we go. I'm going to upload this today. Hopefully it'll be uploaded on the 9th. Let's get right into it. Let's see what this question says. Find the exact values, no decimals, of the 6 trig functions of an angle theta in standard position whose terminal side contains a given point. Alright, so question number 1. I'm going to go ahead and do all the odd ones on this, guys. Question number 1, I have a point. The point is 4, -3. So I'm going to draw a grid. That point is in quadrant 4. So I'm going to exaggerate quadrant 4. So here's quadrant 4. And then 4, -3 doesn't have to be perfect. So 4, -3. I'm going to say 4, -3 is like right there. And there is a way that I can get a line in here, which I probably should use. But for speed, I'm just going to go ahead and just draw that line there. So there's my point. And then I'm going to go. So that point is 4, -3. And here's my right angle. So this horizontal displacement is a 4. This vertical displacement is a -3, and it came out wiggly. That's a byproduct of digital products there. So there's my -3. And it's a right triangle, so I can just do Pythagorean Theorem. The hypotenuse is never going to be negative, guys. So 3, 4, this is a 3, 4, 5 triangle. If you didn't see that, you could have always done square root of 4 squared plus a -3 squared. And to be honest, you don't even have to put a negative in there because you're going to square it anyways. And that would have been the square root of 25, and the square root of 25 is 5. So now we want all 6 trig values. So use the reference angle to help you out. Really, you're getting the angle. That's the angle that you're really looking at. So I'm going to write sine theta. Sine is opposite over hypotenuse. Use the reference to help you out, but keep the negative. So sine is -3, hypotenuse is 5, so -3/5. Cosine angle, and again, here comes the squigglies. Cosine angle adjacent over hypotenuse, so 4/5. Tan theta. Tan is opposite over adjacent, so -3/4. And then the other 3 are just the reciprocals, right? So let's see. Cosecant theta is a reciprocal of sine, so -5/3. And then secant theta is a reciprocal of cosine, so 5/4. And then cotangent theta is a reciprocal of tangent, so -4/3. And there it is, guys, and that's pretty much all you're doing there. So here we go on this one. So we have quadrant, let's see, they're both negative, so that's quadrant 3. And I'm going to exaggerate quadrant 3. So there's my quadrant 3 exaggerated. I put a point, let's see, -5, -7. I'm going to say I'm somewhere like right there. Connect the origin, horizontal, vertical displacement. So this distance here is a -5. I mean, the distance itself is 5, but you're in quadrant 3, so it's negative. That's -7. There we go. So we got -5, -7. We're going to use our reference angles to help us out, but the real angle is actually this one. And here we go, guys. So I'm going to write sine of that angle. So sine of that angle, let's see. Sine is opposite over hypotenuse. Oh, we need the hypotenuse now. So I'm going to do 5 squared. So on the side, I'm going to go square root of 5 squared plus 7 squared. It doesn't matter because if you put a negative in there, we are squaring it anyways. So let's see. 25 plus 49. That is 74, and that's not going to break down, guys. So leave it at square root of 74. They said no decimals. I don't see square root of 74 breaking down. If it was 75, we could have done 25 times 3, when the square root of 25 is 5, but it's not a 75, it's 74. So leave it alone. All right, here we go. Sine theta, opposite of our hypotenuse. -7 over square root of 74. Did they ask us to rationalize it? They didn't ask us to rationalize it. So here's my answer. I'm going to leave it alone. If you want to rationalize it, go ahead. It's not a big deal. It would have been -7 square root of 74 over 74. I'm going to leave it alone. Cosine theta, adjacent over hypotenuse, -5 over square root of 74. And then I'm going to write tan. Tan is opposite over adjacent. So remember, you're dividing two negatives, so it's going to turn out to a positive, guys. So opposite over adjacent, so -7 over -5 is going to be 7/5. All right, now I'm ready for the reciprocal ones. So I'm going to write cosecant of that angle is going to be negative square root of 74 over 7. And then I'm going to write, oops, nope, that is wrong. That's cosecant's the reciprocal of sine. Oh, no, I was right. Darn it. Negative. And then the reciprocal of cosine is secant. So negative square root of 74 over 5. And the reciprocal of tangent is cotangent. Cotangent 5 over 7. I don't see any errors, guys. I think we're good. So that's what I want. Maybe make them a little smaller so you can have more room on the even ones there. All right, so this one says for questions 5 through 8, they terminate on a given quadrant and has a given function value. Find the exact values of the other 5 trig functions. So it looks like I'm pretty much doing the same work, but this time they give you one of them. So they tell you what quadrant you're in. Notice it says quadrant 2. And yeah, in quadrant 2, sine is positive. We don't know the actual coordinate, guys, because it is a ratio. But we can create a coordinate. So let's see. If this is supposed to be opposite and that's supposed to be hypotenuse, I can say that this is going to be, let's see, that y is, so from the origin, or you know what, I'm just going to draw a random, here we go. Just a random. And here's my coordinate, and this is the angle. And I know this is a 4, and this is a 5. So again, this is just a 3, 4, 5 triangle, so it has to be a negative 3. If you want to give, there's my right angle. If you want to make a coordinate there, if you wanted to, you don't have to, by the way. You could say that's negative 3, 4. You can. You don't have to. I'm going to erase it because I don't want to. So there it is. Remember, just sine, cosine, tangent. They're all just ratios, guys. Oh, that happens pretty often there. I don't know why. Something's going on there. All right, so I'm going to go ahead and find all my answers from that. So I already have sine. So let's see. Cosine is negative 3/5. Tangent is negative 4 over 3. I put the negative in the front. It doesn't matter where I put it at. I could have put the negative with the negative 3 there, but it's still the whole number 4 over 3 is still negative. Or the ratio 4 over 3 is still negative. Let's see. What else am I missing? Secant. Secant is a negative 5 over 3. Cosecant. Cosecant is the reciprocal of sine, so 5/4. And cotangent is the reciprocal of tangent, so a negative 3/4. I don't see any errors, guys. Let me make sure again. Negative, negative. Secant reciprocal of cosine. Cosecant reciprocal of sine. There we go. 1, 2, 3, 4, 5. I got them all. All right, let's go. Next one, it says quadrant 4. So I'm going to exaggerate quadrant 4. So here is quadrant 4. And it says secant is 4. So if secant is 4, right off the bat, we know that cosine has to be 1/4. So a point, not to scale, point, I guess it's probably closer to the y-axis. 1/4. That's the hypotenuse. I got to figure out what my vertical displacement is. And you do that by doing Pythagorean Theorem. You're going to have to go backwards though, right? So 4 is the biggest, 1's the leg. So 4 squared minus 1 squared. So 4 squared is 16, 1 squared is 1, and the square root of 16 minus 1 is 15. And let's see, 5 times 3, no, nothing breaks down. So leave it at square root of 15, but negative. So here we go. So we already found cosine, so now let's do sine. Sine is a negative square root of 15 over 4. And then we need tangent. Tangent of that angle is opposite over adjacent. So negative square root of 15 over 1, which is just square root of 15. So there we go. We got cosine, sine, and tan. So now we need cosecant. So I'm going to write cosecant theta, and then maybe put a line somewhere right here to indicate the difference between 7 and 8. Cosecant theta is the reciprocal of sine. So negative 4 over square root of 15. And let's see, what else am I missing? I already got secant. Oh, cotangent. Cotangent theta. Maybe make it neater than me, guys. As you can see, mines are all over the place. Maybe make a column where everything's nice and neat. So cotangent. Let's see, cotangent is reciprocal of tangent. So negative 1 over square root of 15. And there it is, guys. Since I have them all over the place, I'm going to box them in. 1, 2, 3, 4, 5. But if you have yours nice and orderly in one column, that would be ideal. All right, so this one 9 through 14. So I'm going to do these next three here. All right, it says find the exact values of the 6 trig functions of the given angle. So this time they give you an angle, guys. So that 60 degrees there is your angle that they gave you. So here we go. That one's pretty basic. Let's see, at 60 degrees, you're right up there. Your x-coordinate is a half. The y-coordinate is square root of 3 over 2. That's what your unit circle looks like, right? So I'm going to write cosine. And instead of theta, they gave me the 60 degrees. I guess if I write 60 degrees equals theta, you can still write theta if you want. But I think it's better if you just do that. Cosine of 60, that's just a half. Sine of 60 degrees, that's square root of 3 over 2. And then let's see, tangent of 60 degrees, that's y divided by x. Square root of 3 over 2 divided by half, the 2's will cancel out, so you just get square root of 3. For those of you that want to know, like, what do you mean they just cancel out? You can do keep, change, flip if you want, but see, this 2 is in the denominator of the numerator, and this 2 is in the denominator of the denominator. So they just cancel out. So you just get square root of 3 over 1. So now we're going to do the reciprocals. The reciprocal of cosine is secant. So I'll just write secant at 60 degrees. Make sure to put the degree symbol there. Is the reciprocal of half, which is 2. The reciprocal of sine is cosecant of 60 degrees. And it doesn't say to rationalize, so we can leave it as 2 square root of 3. And then cotangent of 60 degrees is 1 over square root of 3. I hope I'm not creating bad habits. I think this is fine as long as you, if it says to rationalize, maybe rationalize it. If you come across an exam that is a multiple choice exam, they probably will not have it like that. They'll probably have 1/3 square root of 3 on the side or square root of 3 over 3. If it doesn't say to rationalize, you can leave it. I think it's, well, I'm not trying to create bad habits, but in the past, they've always wanted to be rationalized. And I think it's something about log rules. Like back in the day, they used to use these rulers or something like that. So tan negative 315. Well, let's see where 315 would have been at. 315 would have been right here in quadrant 4. And so that's if we would have gone counterclockwise. But it says negative, so we're going to go counterclockwise. So we're going to rotate the same distance but clockwise. So that would be in quadrant 1 there. And that coordinate is square root of 2 over 2, square root of 2 over 2. So it's the same as 45 degrees. So I'm going to write cosine of negative 315 degrees is square root of 2 over 2. Sine of negative 315 degrees is square root of 2 over 2. Tangent of negative 315 degrees is going to be 1. Because the magnitudes of x and y are the same, and it's just y divided by x. So now we're going to do the reciprocals. Secant of negative 315 degrees, that is going to be 2 over square root of 2. Cosecant of negative 315 degrees, that's going to be 2 over square root of 2 again. And then finally, cotangent of negative 315 degrees is going to be 1. So there it is. Pretty straightforward, I thought. Let's go to the last one here, guys. So we have 180 degrees. That coordinate is right there. Well, 180 degrees is right there. And the coordinate at 180 is negative 10 on the unit circle. So here we go. Cosine of 180 degrees is negative 1. Sine of 180 degrees is 0. Tangent of 180 degrees is y divided by x. So 0 divided by negative 1 is 0. Secant of 180 degrees is the reciprocal of negative 1, which is itself. Cosecant of 180 degrees is the reciprocal of sine, which is undefined. And same thing can be said for cotangent, because it's x divided by y. And the reciprocal of 0 is just undefined there. There it is, guys. We did it. I hope you guys are happy. Enjoy your weekend and maybe do a little bit of math life. All right, guys. Take it easy, guys. Talk to you guys later.